It can be extremely difficult to recognise the vast chasm that lies between valid, well thought out, evidence-driven theories and ideas that are fundamentally born of desire. Especially when the so-called valid theories are so counterintuitive that they seem to deny reason. Though once one does become familiar with the subtleties of such theories, and so can begin to recognise one for the other, it's understandable why they should want to defend their communities against any further misdirection. Hence why so many of us take a militaristic stance over our convictions. But holding a less convicted, more nuanced stance can be harder still. For when the suppression of opinion equates to war, fence-sitting will only ever be seen as laziness, cowardice, or worse, ignorance. And yet it is there, between the lines, where the truth so often lands. And nowhere is this more true than when dabbling in the metaphysics beyond the shorelines of our understanding. Bohm rejected the claim of many physicists that science will one day achieve a final theory of everything, as science is itself an infinite, inexhaustible process. As he said, the form of knowledge is to have at any moment something essential, and the appearance can be explained. But then, when we look deeper at these essential things, they turn out to have some feature of appearances. We're not ever going to get a final essence, which isn't also the appearance of something. And this will be a consideration worth holding on to whilst we ponder the validity of the ideas discussed across the previous chapters, because what it means is that regardless of what truth may reside within each theory, none shall ever be capable of completing our understanding of reality. For at best, we shall only ever be dealing with finite truths amid infinite unknowns. Thus, when attempting to interpret a unified continuum of process, it's critical that we first acknowledge the fragmentation that is fundamental to all language and human thought. As with the knife that dissects the frog to better understand its nature and life, fragmentation often slices one idea into many, providing a disconnect from that which its initial intention was to understand. And so in this chapter, let us investigate that fragmentation and ponder on what it might mean for consciousness, identity, and the nature of thinghood. So join me as I attempt to unpick the infinities of what is. I'm sure that for many, conceptualizing a world where all is a fluxing whole of undifferentiated process can not only be difficult, but downright irritating. It just feels so wishy-washy. After all, it's natural for us to crave boundaries, as boundaries define our worlds. Because without a fundamental understanding of the bits of objects, things and their mechanical nature, what, if anything, do we have left that we can trust? The nihilistic material philosophy that is on the rise among younger generations has at its roots this very fragmentation. Thanks to the technological revolution, we are each privileged with a very highly educated understanding of the physical world, built upon more than 2 millennia of critical thinking and 3 centuries of scientific successes, speed-fed to us through our many avenues of streamed entertainment, to the point where, for many, the intrinsic qualities of humanity, such as our concepts of love and hate, are thought to be nothing more than the electrochemical processes of the body and brain. Good and evil are thus conceptual constructs, born out of the soulless interplay of these processes. Life is meaningless, as meaning does not inherently exist. We may choose to give meaning to things, but only because that's how this organic machine has learnt to survive. Fundamentally, the universe is atomic, mathematical, and thus mechanical and indifferent. Some of us have gone so far to choose a positive version of this nihilism, proud of such an enlightened, non-religious point of view, humbly appreciating the wonder of existence for what it is, regardless of its futility. While others see the whole picture as being so terribly depressing that they either choose to deny science or just avoid any deeper contemplation altogether. But we should remember that every generation holds this same belief, that the generations prior were all lost within their own closed-minded prejudices, and that it is only we, the first in this long line of succession, who have emerged from their archaic modes of thinking. But of course, we are as influenced by our culture as any who came before. So we must still remain cautious of allowing one voice to dominate the conversation, even when that voice is science and mathematical reason. This should, however, be seen as a dangerous statement to make, especially at this point in our history, as the mechanical view of the universe should be granted a very definite status of validity, considered as aligned with reality as any finite description ever could be. Meaning, on the one hand, that those physicalist interpretations of how minds work cannot be argued. For the universe has indeed proven itself to be mechanically knowable. However, this perspective and its own set of associated truths should never be considered absolute. Valid within its own relevant frame, yes, but not final nor closed to any broader interpretation. What's interesting about the field of physics is that it is a mode of thinking that must bow to two masters, the king of experimental results and the queen of mathematics. The king, as we have seen, is limited in his powers, bound by the uncertainties revealed by the measurement problem. But what of Her Majesty the Queen? In quantum theory, it is, as it was with Alice in Wonderland,
always here, you see, are the Queen's way.
Among physicists, the theories and equations that are considered preferable are those that are mathematically beautiful, those that host traits of symmetry and brevity, what theorists often refer to as mathematically elegant. But as a result, physics might in fact be flawed in its capacity to know deep reality, suffering under its queen with a case of Stockholm syndrome. Now, I am not a mathematician, nor am I a physicist. But with that said, it's clear that even the experts themselves are all too aware of the rigid limitations of their beloved tool. Gödel's incompleteness theorem, published in 1931, shows how basic axioms of arithmetic can give rise to contradictions that cannot be proved or disproved. One example is Cantor's continuum hypothesis, which begs the question, is it possible for an infinite set to have a larger cardinality than the set of whole numbers, but still have a smaller cardinality than the set of real numbers? The answer to which has since been proved to be both yes and no, thus suggesting that mathematics is, and possibly always will be, incomplete, contained as it is to what I like to refer to as lines and circles thinking. It was Aristotle who first put forward the idea that all bodies must have a natural way of moving. As he saw it, once the universe had been put into motion by the unmoved mover, anything that moved henceforth would do so because it was moved by something else, knocks and bumps that pushed bodies along their strict trajectory of straight lines. 2 millennia later, Newton's famous law of motion that an object will remain at rest or in uniform motion in a straight line unless acted upon did again seem to follow in this very same line of reasoning. However, Newton's thinking also introduced a second kind of movement, being the movement of gravity, that of circular motion. But what inspired these thinkers was not necessarily experiment, nor even a first-hand experience of movement. These were logical, mathematical insights unveiled by a skill and knowledge in geometry. Where circles again arise in mathematics is in those occasional infinity wells that can pop up in equations, the most blunt example being the descent into pi. But whether it's time's simple ticking from 1 second to the next, or Einstein's non-Euclidean relativistic space-time manifold, the point is, when we think about math, we're more often thinking about shapes. And so, confined to our 2-bit toolkit, we go about drawing our abstract, multi-dimensional shapes atop a fluid analog reality, hoping desperately to trace its outline. Where this process gets interesting is when, in algebra, we begin substituting these linear-bound numbers with abstract ideas, symbols that can move along a totally different geometrical axis, investigating structure, forms, and above all, relationship. But the inherent issue is that any logic lifted from the system will always be coloured by these fundamental limitations of lines and circles. Another important figure in the development of quantum mechanics, Wolfgang Pauli, put it to us thus, that, quote, "A symbol can only be partially expressed by conscious ideas. Another part of it acts upon the human unconscious or preconscious. The same holds for mathematical notation, for only those have a talent for mathematics who are capable of appreciating its symbolic power." End quote. In other words, there is form to be considered between the lines. In fact, infinity in physics is practically always considered bad news. Quantum electrodynamics theory, or QED, only works for us as well as it does because physicists renormalize their equations. Quote, "The infinities are still there," says Feynman, "but now they can be skirted around. We have designed a method for sweeping them under the rug." End quote. Paul Dirac, another prominent figure, condemned this carefree approach of arbitrarily neglecting infinities, stating that, quote, "Sensible mathematics involves neglecting a quantity when it turns out to be small, not neglecting it just because it is infinitely great and you do not want it." End quote. Indeed, the uncertainty principle itself reveals this shortcoming by showing that we cannot know two related attributes of a particle simultaneously, with this failure in perception flagged by the rearing heads of those same circular infinities. So it seems that this move into the abstract is a necessary one, because what we need to remember is that neither the straight lines nor the circles actually exist. These are merely constructs of our perspective. And so, whilst we must acknowledge that mathematics does have the ability to open up new and exciting domains of understanding, we must still try to remain aware of the fact that there must also be alternate framings of reality through which no line or circle can ever persist. Truths about how reality, of which no traditional mathematical or mechanistic understanding can hold any insight. But even though we know mathematics and measurement are limited, we, as a culture, seem to have happily placed our salvation in its hands. For if any individual follows the progress of science and assumes that this progress is synonymous with the uncovering of absolute universal truths, then what they have essentially done is put their faith in the truth of math. But mathematics is no God. It's a confined, relative infinity. Accurate and true, but only from within its own relational frame. As Bohm said, we're not ever going to get a final essence which isn't also the appearance of something. So, what does all of this say about what is actually real? As highlighted by M.C. Escher's famous woodcarving Sky and Water, it is often the perspective concerning the spaces in between that needs our closer attention. For is it an image of fish swimming in the ocean, or are those spaces in fact birds surrounded by empty sky? As with our own hunt for natural borders, it has not just been the individual parts that host an actuality of existence, but also the relationships between the parts. Because nothing, be it mathematics, objects or consciousness, can exist in a vacuum. Indeed, nature abhors it. In fact, each structure acquires its very identity through this process of relationships. So, are the birds bits of the universe and the spaces between merely relationships? Or are the fish the bits and the birds the relationships? The answer, as with Escher's piece, is yes. Both. Relationships are universal entities in their own right. When a skilled swordsmith balances a sword on their finger, it's known that they will find a central point of balance where the object will happily rest without falling. That point is not a thing as such, but it does exist in a meaningfully relevant way. Indeed, as we seek out a quality of identity at the finest resolutions, it appears that the objective nature of things gives way to this domain of relationship. Nodal points that may have a truth, an influence, and an existence, but one that goes beyond our usual concept of matter and thinghood. Matter, as we experience it, is an emergent property whose appreciation becomes relevant only as we encroach upon our more familiar scales. And therefore, it is not that the relationships of objects are to be considered more fundamental, existing on some deeper level, but that the objects themselves are relationships. Perhaps an easier way to imagine this is to consider water and its various states. On the surface, ice, liquid, and steam are as different from one another as anything ever could be, and yet, fundamentally, ice, water, and steam are all considered one and the same thing. Despite their entirely unique characteristics, it is only ever the relationships that change. What this analogy also makes clear is that it's not merely the relationships underlying the parts of the structure which give rise to its appreciable identity, but also the extended relationships that each holds with the surrounding environment, such as, in this case, its temperature. The underlying relationships thus relate to these external relationships, summing to form an appreciation of some whole that we can then label. Likewise, consciousness can be considered just another of these universal relationships, as all that exists in consciousness is born of this same universal energy. And it is with an appreciation of this finite perspective that we can shine a light on how other natural relationships relate to and thus incorporate consciousness as a relational phenomenon. Consciousness, too, is a confined infinity of sorts. But like mathematics, it too tells us something important about what reality actually is, in that this is a world where both can and do exist. It is a universal flux that seems capable of both being known and knowing. But as with the knowable, offered by mathematics and measurement, so too must we ask of the knower, what is its finite frame? What is its meaningful context, and therefore what does it miss? Many worlds theory, beyond its metaphysical interpretations of infinite universes, is actually very relevant to understanding the extended relational quality of consciousness. The theory itself makes no claims upon consciousness one way or the other. However, the way universal branching is often described to a layman is through an example of choice. It is said that when we make a decision, take a walk, write a book, it is that choice between two possible potential outcomes that is responsible for the branching of universes. Not because consciousness dictates reality, but because these theorists see choice as a physical act. As we make a conscious decision, quantum events unfold in our brain, events with physical outcomes that lead us forward on a path towards a particular future. And so, beyond many worlds, it is with this idea that consciousness can now be offered in terms of a participatory influence. An influence that might participate in reality in a way that is, at very least, comparable in status to the other fundamental features of nature. Now, to be clear, I'm not suggesting that we alter the standard model of physics to incorporate consciousness. Rather, just that as the standard model defines gravity by its behavioural role rather than any deeper substance, so too am I defining consciousness by its own irreducible participatory role, since again, no deeper substrate can be offered. So, as gravity gravities, and electromagnetism both electrifies and magnetizes, so too does consciousness conscious. Which may come across as a ridiculous statement, but the point is, we should see more in this scenario that is similar than is different. As in quantum field theory, where the fields of force not only interact but give rise to one another, so does consciousness have a place within this interdependent harmony, both in the relational context via a physicality shared equally by both brains and universe, and in how emergent minds participate, playing their own part in the influencing of these greater energies through a process of thought, action, and reaction. For the average materialist, it is practically impossible to distinguish between the acting agent of free will and an individual's neurological mechanics. But in consideration of the above, can we now claim that the nature of will does exist relative to its own particular frame of relational meaning, but that equally, so too does the brain's neurological functions only remain meaningful within a particular context, as both stand relative to their own finite domain of reason, with any definition of hierarchy only ever being an attribute of one frame or the other. In short, free will, neurology, and their relational structures each derive their identity from their contexts. Because the extended field of reality will be affected equally by all transactions of information, physical, conscious, or otherwise. The influence of shifting energies moves through us in the form of awareness and ideas, as our awareness and ideas move onward through the shifting energies of our actions and reactions. We are therefore interfering with our worlds through a force of being. But what's crucial to appreciate is that this is not a one-way street. For we may ask, could we have made a different choice to put down the pen or play on our phone? And the point is that this projection of alternate possibilities is only a further aspect of our current framing. Since if I were going to do that, I would have, but I didn't. It wasn't forced upon me, it is what I am. Our will, choice, and actions are not separate from the self, any more than the self is separate from the universe. Each context, subjective or objective, merely ignores different aspects of the bigger picture, each real, valid, and unarguable from within that frame, and yet each infinitely incomplete, a trope that now seems attributable to all finite identity. Of course, we could, in any example, broaden our scope to include larger sets of facts, but, as shown, we never encounter the absolute boundaries that would be necessary for one to determine something as either absolutely true or absolutely false, as absolutely mind or absolutely matter, as absolutely meaningful or absolutely meaningless. In a finite frame, free will is real. In a finite frame, our decisions are made uniquely by the I that I consider unique and independent. But in another, equally finite frame, the universe is just doing what it has done for the last 13.8 billion years. It's just that now, that process results in my decisions. And yet, beyond each relative frame, there is no absolute cause, for again, it is never a one-way street. Now, this will give us something to consider and investigate over the following chapters, because what we found is that the energy and information of the world moves through us, merging with our own becoming and back again, as our influence extends into those external systems, playing its part in the becoming of the moment. The things we do, the way we act and behave, our instincts and will are all natural traits of this universe. And so do they each equally contribute to the shifting of energies, just as any attribute of physics might. So if we are to give our description of consciousness any of its deserved dues, then we must consider, and now investigate, the ways in which this trait appears to be active, so that we might better understand what role it is that the conscious self is actually playing, be it participatory, relational, or both.